So we have already discussed two types of design patterns. One is creational design patterns, which is basically dealing with object creation, right? How you can centralize the object creation logic. That is what all about creational design pattern. And we have already completed the another category of a design pattern, so which is nothing but your structural design pattern. Structural design pattern is all about the how you are going to manage the relationship between multiple classes and interfaces, right? And today we are going to start the last category of a gang of a design pattern, which is nothing but your behavioral design pattern, right? So this behavioral design pattern is basically dealing with how you are going to communicate between classes and object, right? So it's deal with the communication, or you can say interaction between multiple classes and multiple objects. See, whenever we are developing any real-time application, don't think that we are defining one method and that method is going to do all the tasks. Sometimes what we need to do, we need to interact with multiple methods, and multiple methods belonging to multiple different objects, right? So what is our intention? Our intention is, if I'm requesting, if I'm calling one method, right, then that method is going to call another method calling another method. That means in that scenario, we are dealing with multiple method. Multiple method might be coming from multiple object. That means we are communicating with multiple object. Then this effectively you are going to communicate with those objects, right? So communicating those object means, see, whenever we are communicating with multiple object, but the main fundamental thing is loosely coupled. The application should not be tight coupled, right? If I'm changing one object, then it should not affect the other object. In that way, we need to communicate between those objects. So this is all about your behavioral design pattern. You can read the definition. Behavioral design pattern deals with the communication or interaction between classes and objects. The interaction between the objects should be in such a way that, so whenever I'm saying between object means there are some method that are available as part of that object. Those methods we are going to consume, right? So should be in such a way that they are talking to each other. That is one object talking with another object, but still they are loosely coupled. Still they are loosely coupled means if we change one object, then it will not affect the other object. And guys, remember, if your application is loosely coupled, then you can implement the entire architecture. And the entire architecture means the component should be loosely coupled. So in behavioral design pattern, there are 11 types of design patterns. You can say iterator, observer, change of responsibility, interpreter, command, memento, mediator, state, template, strategy, and visitor. So we are going to discuss all these design patterns, right? So today I'm going to target these three design patterns, right? And tomorrow I'm going to target these five design patterns. And the last day of Monday, I'm going to complete these three design patterns, right? So tomorrow is Sunday, right? So people are having more time, so we can take more time on the classes. But today I'm going to cover these three design patterns, right? So let us start the discussion with our first design pattern of behavioral design pattern category, that is observer design pattern. Observer, iterator, and chain of responsibility. These three design patterns we are going to discuss today. So what is observer design pattern? Let us first read the definition what according to Ganghofer. So Ganghofer saying that define a one-to-many dependency between object so that when one object state changes, all its dependencies are notified and updated automatically. So this is the definition which is provided by Ganghofer. Let us simplify this definition. So the observer design pattern is a software design pattern, no doubt about it. We are learning software design pattern only in which an object, see, whenever I'm saying object, let's introduce some technical term. Let's call that object as a subject, right? Let's call that object as subject, maintains a list of its dependencies. Dependencies means observer. These are also objects, right? One object containing a list of object and notifies them automatically whenever any state changes by calling one of their method. What it means that this is object having many states. This is object having many states, and these are nothing but your observers which are registered with this object, right? And whenever any state changes, suppose the current subject state is A, it changes to state B. then whatever changes are happening with the subject, it should notify to all the observers which are registered with this subject. How it is going to notify? Now this observer having some kind of method, and this subject will call those methods. If this is not clear at the moment, don't worry, we'll take some kind of a real-time examples, right? So how does the observer design pattern work? So basically there are two components. One is subject and another is observer. See, these subjects are also called as publishers. When a change occurs to a subject, it should notify all of its subscriber or observer. So if there is a Facebook group, and if I'm subscribed to that Facebook group, whenever someone publish any post, then that post will be available to all the persons who are subscribed to that Facebook group. So in this case, that Facebook group is nothing but the subject, and who are the observer is nothing but we people, sir. We are subscribed to that Facebook group means we are the subscriber, and subscriber is also called as observer, right? And the Facebook group is going to be the subject, right? And whenever a new post posted on the Facebook group, that information, that post information will be notified to all the observers, right? Again, you can take the example of a YouTube channel, right? There is a YouTube channel and you have subscribed to that YouTube channel. Like you, many people are also subscribed to that YouTube channel. Whenever the YouTuber post a video on his YouTube channel, that means post means he is the publisher. Whenever he publish one video to the YouTube channel, then who are the subscriber? Those are who are subscribed to that YouTube channel. They will get some kind of a notification. Who is sending that notification? YouTube only sending that notification. So here YouTube is nothing but the subject, and we people who are subscribed to that YouTube channel is nothing but the observers or subscribers. See, for better understanding, look at this image, right? So this is the subject. Subject has states, and subject maintains list of observers. Who are the list of observers? Who are registered with the subject? You cannot send notification randomly to anyone. You can only send a notification to those people who are subscribed, right? So this subject having two things. One is subject having state. State means state one, state two, state three. What are the state we will discuss in detail, but let's assume that there are some states, and this subject having some kind of methods. What are the method? A method is for registered and unregistered. If one observer want to register with the subject, then this object needs to provide some kind of mechanism for the registration purpose. Similarly, he has to provide some kind of mechanism for unregistered. Suppose today I subscribe, tomorrow I want to describe that what I can say. I don't want to subscribe, I want to revert. So for that purpose, you need to provide some kind of mechanism, as well as there should be some kind of a method which should send the notification to the observers, right? So here observer will subscribe to this subject by using the registered method, and the observer can unsubscribe from the subject by using the unregistered method. So any number of a subject, any number of observers can subscribe to this subject, right? So let us understand this with one real-time example. Suppose you might be know the Amazon website, right? Amazon website. Let us assume there are three users: user one, user two, and user three. These three users going to the Amazon website, and all these three users are searching for one mobile phone on the particular website, that is Amazon. A particular mobile phone. Let's assume that mobile phone is a Apple iPhone. Apple iPhone is very costly for us, so let's thinking that the red MI phone, right? So this three user one search MI phone. User two also search the particular model of the MI phone, and same in the case of user three. What is happening now? While they are searching on the Amazon website, that mobile phone is not available at that moment. That means that mobile phone is out of stock. The quantity available is zero. Quantity available zero means you cannot buy that particular product at that time. And at that time, you will see this out of stock option will be shown there, right? But these three users are interested with this mobile phone. So here the mobile phone is nothing but you can see the product which you want to buy, but that product is not available. So here not available means out of stock is one of the state of this product. So if you will see the Amazon website, there is an option called notify me is there, that right? And that notify me option is only available whenever the product is out of stock. And if you click on that notify me product, right, notify me button, then you are subscribed to that product. And whenever the product is available, then that Amazon website will send you a notification. So like you, user one, click on that notify me button. User two also click on that notify me button. User three also click on that notify me button. That means these three users are subscribed to that mobile product. And only when that mobile product is out of stock. If the mobile product is available, this notify me button is not there. Instead, buy me product or buy product option will be there. So notify me means when the product is out of stock. That means there are two states of this product. What are these? Out of stock and available. So whenever the out of stock is there, this notify me button option is there. And users, right? Any number of users can click on that notify me button. So in this example, this mobile is nothing but your, what I can say, publisher. And this user one, user two, user three, these are nothing but your subscriber. And the state of this mobile phone currently is out of stock. And these three users are subscribed to this product by using the notify me button. Tomorrow or after few days, the product is available. So once the product is available, then what will be happen? The change of the change when the product is available, the state is going to be changed, right? The state is going to be changed from out of stock to available, and whenever the state is changes, this publisher will send notifications, right? Will send notification to whom? Those subscriber who are subscribed. And in this case, as the state is changed from out of stock to available, so this subscriber will send, this subscriber means publisher or you can subject, right, will send notification to all the observers who are registered, right? So this is, in this case, they will send one notification to user one, same notification to user two, user three, and once the user get the notification, then if he want, then he can go to the Amazon website and buy the product. It's completely depend upon the observers, or you can say subscriber. Clear, guys?
Yes.
Right. Now if you read the definition, then you will understand this clearly. So the observer design pattern is a software design pattern in which an object called a subject, in this case mobile product, maintain a list of its dependents called observer. Observers nothing but the users, right, who are subscribed to that product, and it notifies them automatically whenever any state changes. Whenever the state of the mobile phone is changed from not available to available, at that time that mobile product or the subject will send a notification to all the observers who are registered with them, right? So this is one of the best example of what I can say, your observer design pattern, right? And this kind of functionality you will find in any kind of web applications. Let us implement this example step by step, and then I will explain you the UML diagram, right? So let me create the iSubject interface. The technical term, these are the technical term, but you can give any name. So let me create one application observer design pattern with the name of. So I have created one folder called behavioral design pattern. Inside this folder, I am going to add a project, and the project name is going to be observer design pattern, right? So once I have added, let me create the iSubject interface. This is the subject interface. This is going to provide the functionality to which the concrete subject is going to be implemented, right? As our main intention is loosely coupling, so we are going to start with the interface, right? Let me copy the code, then I will explain, right? So this is the subject interface. And what is this iObserver? See, as we are going to communicate between multiple objects. So this is one object and this is another object, right? We are going to create this observer object, right? We cannot create both object at the same time. You have to create one by one. So sometimes you will get this compilation error. Later we are going to create this observer interface. So as you can see, this object interface having three methods. One is registered observer. Any observer or any subscriber want to register with the subject, they have to call this register observer method. Remove observer means unsubscribe. And notify observer means this object is going to send a notification to all the observers who are registered with the subject. These are the three methods. And while how it is going to send the notification means it is going to use one of the method which is defined by the observer. It is going to, the subject is going to call the method of the observer. How it is going to call, that we will see. But for now, this object having three abstract methods. One is registered, another one is remove observer, and the last one is notify observer. So here the observer is going to register, here the observer is going to subscribe, and here the object is going to send a notification to the observer, right? So once this is done, the next step is to create the concrete interface, right? So concrete subject. Let me create a class file with the name subject.cs. Subject.cs. This is going to be a concrete class, and this class is going to implement the iSubject interface. iSubject interface means it is going to provide the functionality. It is going to implement the method which are defined in the iSubject interface. If you see here, three methods are defined. So these three methods are going to be implemented by this class. See here, you can see this is iSubject interface, right? iSubject interface. Getting some compilation error. Don't worry, we'll clear this compilation error after some time. So first of all, this object having uh, subject means it's a product. In our example, the mobile phone. So what is the mobile phone? That name, product price, and this availability, it is going to store the state of the mobile phone, whether the state is available or whether the state is out of stock, that is going to be stored by this availability property. And I, first of all, I need to create the product, right? Or you can say I need to create the subject. For creating the subject, I need to use this parameterized constructor. And for this parameterized constructor, I'm taking the product name, product price, and availability as the parameter and initializing these three subject properties, right? So this is fine. And then this is the get availability method. And this method is going to return the state of the subject, right? So what is the state? State means what is the value stored inside this availability variable. Whether the value is available or out of stock, that is going to be returned by this get availability method. Similarly, set availability method means suppose initially the product is out of stock and later you change this stock, later you change this to some different state. Different state means what? From out of stock to available, right? Then you can set that using the set availability. This set availability method is going to set the, this is going to update this availability property value from out of stock to available. And once it is stock, right? Then what I'm doing here, I'm saying that availability changed from out of stock to available, right? This is the message I'm saying, but this is not done. Then once the product state is changed from out of stock to available, right? Then we need to notify all the users, right? All the users means you can see I have created one variable, right? I'll come to this notification part later, set availability method later. Before that, I need to show you two things. One is a registered method. You can see I'm having this registered method and remove user method, right? So this registered method means one observer, right? If he wants to register with this mobile phone product, then he needs to call this method. So you can see iObserver interface, it is taking as a parameter. Any child implementation of this iObserver, you can pass. And here saying observer added, right? Whatever the observer, right? That username I'm showing in the console. And then you can see I'm adding that observer to this observer's collection variable. So it is a list of a collection. List of a collection means it can store a list of an element whose type is iObserver. Which type is iObserver means the child classes which implement this iObserver, that child classes I can store here. And here, this child classes is nothing but the list of a subscriber or list of a observer. So I have added, and for this adding purpose, I'm calling this observer.add method, right? And what is this add observer method? This is not required. This is not required, right? So this is the registered observer, right? Once the observer is added, if any observer want to unregistered, then he has to call this remove observer method, right? So once he call the remove observer method, later the user is not going to send the notification. And this is the notify observer user method, and you can see notify observer. And this is the method you can see product name, product price, product price. So product name is this, product price is this, is now available, right? So notifying all the registered user, and for notifying, what he needs to do, he is going to look through this variable, and from this variable he will get the information of all the observer. And once he got the observer object, and this object method is going to be defined in the observer class, and this observer class update method means use this the subject is going to call this object method of the observer class to send the notification that this product is available, right? And here now we'll come to this set availability. Set availability means what? Now this once you call this method, once the this method is called, means what? The product is available, the state of the product is going to be changed. The state is changed from out of stock to available. Once the product state is changed, then we need to notify. So we are not going to use this notify observer randomly, right? Anytime you cannot call this method, or you cannot call this method from outside, right? You only need to call this method, right? So you only need to call this method. So it's better to make this as protected. So can I make this as protected? Right. So you only need to make call this method, right? Whenever the state is changes. And how you know when the state is changed? Whenever this method is called. When this method is called, the state is changed, right? You can see this is the availability variable of the product, and the state is changed from whatever the state you send. Generally, it is going to be available, right? So then you need to notify the observers. And once you call this method is going to be execute, and this method, as discussed, it is going to notify all the observers or subscribers, right? Now let us create the observer interface. The subject part is done. Now we are going to dealing with the observer. You can see I observer, we are getting some kind of a compilation error. We need to fix those errors, right? So first of all, we need to create the observer. This observer is nothing but it is going to be an interface, right? And this interface is going to define how many methods. If you see this observer dot update method, right? Using this update method, the subject is going to send the notification. So we need to create the observer with one method that is called update, and this is the method which is going to be implemented by the concrete observer, and the subject is going to call this object method to send the notifications, right? Then let us create the concrete subject, a concrete observer. Let me give the name as observer.cs. This observer class going to implement the update method, and this update method is going to be called by the subject to send the notifications. Let me implement this. So this is the username. This username is nothing but the observer username, and I'm initializing this observer username. And here you can see this is the subject, right? So whenever I'm creating an instance, so I need to tell if the user is going to subscribe, then what is the subject, right? Subject in the sense, if you see observer is going to click on the notify me button, that notify me button basically belongs to a particular product. Then what is that product? That product information, it is going to be stored inside this subject reference subject variable. So I subject means this is the subject, and this subject is one of the concrete product of the subject. That subject object, it is going to store here. And then if you see, we are initializing the username, and then this subject dot registered observer, right? This subject class having the registered observer method, and calling that registered observer method by passing the this means the current object. Current object means which one? The observer. So passing the observer, we are registering the observer within the subject. And this is the update method. This update method is going to be called by the subject. You can see here it is calling the update method to send the notification. One here it is saying this hello username product is now available. So this method, right? If you are creating, if 10 users are subscribed to this product, then this update method is going to be executed for each user, right? So this is the subject. Now we need to test whether the functionality is working fine or not. For that purpose, we need to modify the client code. And in our example, the main method is the client. Let me, okay. So first of all, you need to create the subject, right? So if you see, while creating the subject, how many things you need to pass? Why I'm getting this error? Notify object. This is public because by default interface members are public, right? So if you see while creating the object, you need to pass three things: product name, product price, and availability. So what I'm saying, red MI mobile, product price is this, and the state of the product is out of stock, right? Then what I'm doing, I'm creating observer 1, observer 2, and observer 3. So while creating the observer, you need to pass the observer name as well as you need to pass the subject to which the observer is going to register, right? And here you can see I'm passing this red MI. This is my subject. Anurag is registering with red MI. Pranay is registering with red MI. Priyanka is also registering with red MI product, right? So we have created the subject, we have created the observers who are registered with the subject. That means currently, if I call this current state property, readmi means what? This is the subject. And in subject class, there is a get availability method. What it is going to return? It is going to return the state of the product, right? And what state it is going to return? If I call this get availability at this time, it is going to return me out of stock because we have set this value, right? Now, if you see this class is also having the set availability method, right? So what is this set availability method is going to do? It is going to update the state of the product. So in this case, what I'm passing available, right? And once I pass available, so that is going to store inside this availability variable, right? This is the property of the subject. And then it is going to notify all the observers. Later, at some point of time, if the state of the product is changed, then this changed information should be notified to all the user. And in our example, who are the user? User 1, user 2, and user 3. So it should notify. And for that purpose, if you see, it is calling this notify observers method, and the notify observers method is going to fetch the details from the observer. This observer is nothing but containing all the user information, in this case user 1, user 2, and user 3. And then it is going to call the update method, right? You can say update method, and in user class, I mean in the observer class, there is the update method, right? That is going to be executed. So now, if now you might be a question, sir, or to us, so how we can implement the unregistered functionality? Yes. So you have to define one method, public. Uh, let give me a void on subscribe, unsubscribe. Call this one, right? And then subject dot, right? And here, uh, hmm, suppose I want to unsubscribe this one, user 3 dot unsubscribe. And to this, what we need to pass? We need to pass the subject, right? So this is how you need to provide the unsubscribe functionality. Now let me run the application. Oh, I need to set this as the startup project. See, observer added Anurag, Pranay, Priyanka, read my mobile current state is out of stock. Availability changed from out of stock to available. Product name RedMI mobile, product price is now available, so notifying all registered user. So here you can see only the notification sent to Anurag and Pranay. Why? Because the other user is unsubscribed, right? For that purpose, what I can do here is I need to give one message, right? That observer subject observer added. So here you can give this message observer remove, right? Observer remove. So now run the application and then you will see that observer removed option. Product is, see, observer added, observer removed, readme mobile. Okay. So where I have removed that observer on subscribe, right? Let me take this out of this. So before subscribing, I need to do this. See, observer added Anurag Priyanka, current state is out of stock, observer removed Priyanka. Now then availability changed from stock to available. This is the message, and you can see the notification is sent to Anurag and Pranay. Clear, guys? So these are the observer who are subscribed to this RedMI's object. And whenever the state of the RedMI's object is changed from one state to another state, that state changes notification, it is sending to all the observers who are registered with the subject. For sending the notification, it is going to use one of the observer method. And in this case, which method is this? Update method. You can give any name, but as per the standard, I'm giving this name as update. Clear, guys?
Yes.
Right. So now if you look at the uh, diagram, UML diagram, so you will see there is a subject, concrete subject, right? Subject interface, it is providing all the methods. And in our example, this is the I subject interface. Registered observer, remove observer, notify observer. So register, remove, notify, and this is going to be implemented by the concrete subject. This concrete subject means it is going to add a remove observer, set or get the product state, send notification to the observer, right? So if you go to the subject class, then it is going to what I can say, add get availability, set availability is nothing but setting and getting the state of the product. Registered observer, remove observer means it is nothing but adding and removing observer, and this is notify observer means it is sending notification to the observer. Add or remove observer, set or get product state, send notification to the observer. Similarly, observer, this is having update method. This update method is going to be implemented by the concrete observer, right? So this is my I observer interface having update method. This is implemented by the concrete user update method, right? So here additionally I have provided this unsubscribe method, right, to unsubscribe the user, right? And for the registration purpose, I'm registering, right? If you want to do the things separately, see, for separate purpose, you can do the things like this. Suppose you don't want to add the subscriber while add the observer while creating, right? You want to do this in a different functional. You want to create it as additional. So you can write here add register, add add subscriber, and from this you can see a registered observer, right? So here you can do like this, and here you can simply comment this one, right? Here you do not need to pass this one, right? For this, what do you need to do changes? The changes is observer, you need to remove this one, you need to remove this one, and you need to remove this one, right? And then how you are going to register? Now user one dot add a subscriber into which product you want to add readmi. So you need to call these things separately, right? If you are getting confused why I'm going to register the user while creating, I want to do it separately, it is also possible like this, right? Now you can see this add subscriber, it is going to register, add and this unsubscribe means it is going to remove, right? So once you run the application, you will get the same output as the previous version of the program, right? We are getting the same out. So it's completely depend on you. While creating the user, you want to subscribe to the product, or you can provide an additional method where you are going to subscribe to the subject. So it is completely depend upon you. Clear, guys? Guys, clear? Or anybody having any question?
Yeah,
So,
clear.
okay. The next design pattern what we are going to discuss is chain of responsibility. So chain of responsibility you can implement in two different ways. I will give you two different examples to understand this concept. This is one of the important design pattern like the previous one, right? So what is change of responsibility design pattern according to Gang of Four definition? So the chain of responsibility design pattern state that avoid coupling the sender of a request to its receiver by giving more than one receiver object a chance to handle the request. Chain the receiving object and pass the request along the chain until an object handle it. So in simple word, we can say that chain of a responsibility design pattern creates a chain of a receiver object for a given request. Right? In this design pattern, normally each receiver contains a reference to another receiver. If one receiver cannot handle the request, then it passes the same request to the next receiver and so on. One receiver handle the request in the chain, or one or more receiver can also handle the request in the chain, right? Let us understand this above definitions with one example, right? So what he is saying now, chain of a responsibility design pattern create a chain of a receiver object for a given. So what it means? It means if you are sending one request, then that request is not going to be handled by one method. That request is not going to be handled. It might be handled by one method, or it might be handled by multiple methods. But those methods should be chained together, right? To clearly understand this thing, here you can say I have created receiver one. So receiver one means you can consider it is one class, receiver two one class, receiver three one class, receiver. You can create n number of receivers, right? This receiver having some method, and the client will send the request to the first receiver. So you can see they are chained together, right? Chained together means what? Now receiver one having a reference to the receiver two, receiver two having one reference to the receiver three. Having one reference means what? Having an object, I write having an object reference of a receiver two, right? This receiver one having one object reference of a receiver two having an object reference of a receiver two, and receiver three having an object reference of a receiver N. And the client in this case will send the request to the first receiver in the chain of a receiver. In this case, receiver one. The receiver one get the request from the client, and he will check whether I am able to handle the request or not. Yes, I'm able to handle the request. Yes, that's fine. After handling the request, is the complete request is handled by me? Yes, completely request is handled by me. Then it is not sending that request to the next receiver. Simply it returns from here. Let assume that let us assume that receiver one cannot handle the request alone, right? Whatever task he can do, but still that is not completed. Then what he will do? He will transfer the request to the next receiver in the chain, which is nothing but receiver two. So how it is going to pass that? Because receiver two, receiver one having a reference of a receiver two, and using that reference, it is transferring the request from receiver one to receiver. Then receiver two will check whether I can handle the request or not. If I am able to handle the request, then I will handle the request and I will return from here. If I'm not able to handle the request, then I need to delegate this request to the next receiver in the chain. And for receiver two, who is the next receiver? Receiver three. So this receiver two will delegate the request to the receiver three, and the receiver three again is going to do the same thing. If he is able to handle the request, then he is going to handle. Otherwise, he will delegate the request to the next receiver in the chain. So in this way, a particular request, right? A particular request might be handled by a single receiver or might be handled by a combination of a multiple receiver. Or it might be, say, in this case, receiver 1 doing some a part of the task, receiver 2 doing some part of the task, receiver 3 doing some part of the task, right? Receiver N is also going to do some part of the task. And combined together, multiple receiver handle the request and then return. Other scenario is also possible that receiver 1 handles some part, receiver 2 handles some part, but receiver 2 check and see that the request is completely handled. Then in that case, it will not forward the request to the receiver 3 and receiver N. Another scenario is that out of all the receivers in the chain, if any receiver handle, then he have to complete, then that receiver needs to completely handle. See, receiver 1 check, I'm unable to handle this request. So he is not going to do the task partial. He will forward the request to the receiver 2. Receiver 2 completely handle the request. See, partial implementation is not possible. We are not going to provide partial implement, either handle or forward. Partial is also possible. That is one of the scenario. Second scenario, completely possible. So that is what I'm saying here. One receiver handle the request in the chain. Either one receiver handle the request in the chain, or one or more receiver handle the request in the chain. If one receiver handling the request in the chain, that means he will not forward the request to the next. Once he handle, simply from that place it will return. One or more receiver means partial handling is there. One receiver handle 25%, another receiver handle 50, another receiver handle 25. But when the request is completely handled, from that place it is going to return. But in this case, if one receiver means partial is not possible, one or more means partial is possible. If still this is not clear, we'll understand by taking one real-time example, right? So I think the ATM machine is one of the best real-time example of what I can say, chain of responsibility design pattern, right? So as you can see, this ATM machine having 4 handlers, right? 4 handlers means there is a 2000 handlers which is going to produce 2000 nodes. There are 500 handlers which is going to produce 500 nodes. 200 handler is there which is going to produce 200 nodes, and 100 handler, the responsibility of 100 handler is it is going to generate or it is going to give you 100 nodes, right? One person, let's say Anurag, come into the ATM. And Anurag wants to withdraw 4600 from the ATM. And he entered the debit card, he entered the PIN, he select that I'm going to deduct the amount from my current or my saving account, and then he select the amount to withdraw, and he select the amount as 4600. And whenever this is nothing but this is 4600, what is nothing but the client sending the request, right? Once the client sends the request, there are 4, you can see receiver 1, receiver 2, receiver 3, and receiver 4. And in this case, I'm creating 4 handler means 4 receivers, and these 4 receivers are chained together. So the request will first go to the 2000 handlers. The 2000 handler will check whether I can able to handle this request and return the amount 4600 using 2000 node. Can this handler alone handle this amount? No, he cannot handle, because he is going to generate the nodes which is 2000, right? And in this case, he is going to generate 2000 nodes. But after 2000 nodes, he cannot generate 3000 nodes, because if he generated 3000 nodes, it is going to be 6000. But the amount is 4600. That is not possible, right? So in this case, he is generating 2000 nodes. And after generating 2000 nodes, is the request is completely handled? No, still 600 amount is pending. So what this 2000 handler will do is he will forward the request to the next handler, which is chained together. And in this case, this next handler is 500 handler. Then the 500 handler will check whether I am able to handle this request or not. And he checked what is the amount 600. How many 500 node I need to generate? One 5000 node. After generating one 500 nodes, is the request is completely handled? No, because still 100 is pending. So as 100 is pending, so what this handler will do is he will forward the request to the next handler in the chain. And the next handler in the chain is 200 handler. So what this 200 handler or this receiver will do is he will try to figure out whether I'm able to handle the request or not. So I can only generate 200 nodes. And what is the remaining amount? 100. So I'm not going to handle anything. So what this 200 handler will do is he will forward the request to the next handler in the chain. And what is the next handler? 100 handler. So he is going to see how many nodes I need to generate. One node, 100. And what is the remaining balance? Remaining balance is 0. So in this case, it is going to handle the completely request by using this 4 handler. So it is going to produce two 2000 node, one 500 node, and 100 node. Clear, guys? This is how happening in the ATM machine or not?
Yes.
Right?
Yeah, yes, sir.
Yes.
Right. So now what is our intention? We need to design, right? Previously, we have discussed one real-time application, how you are going to implement the notifications, right? That is also one real-time application if you are developing e-commerce application. But this is also one application, right? If you are going to work with any banking sector, then you are going to work some kind of things. Because in ATM machine, they are using, but internally software is there, na? Which is going to decide how many 2000, how many 5000, how many 100 notes are going to be uh, uh, how given to the customer, right? That is also going to be done by some kind of software, right? So now our intention is we need to implement this application using chain of responsibility design, right? Let us see how we are going to implement this. Clear? Well, first of all, you guys understand what is our requirement?
Yes.
Right. Suppose the user send 4650 rupees. Is that a valid amount for this ATM machine?
No.
So
No,
that means
there are
in
no
that
50
case,
rupees handlers.
right? So in that case, we need to immediately give one message that invalid amount, right? Instead of checking this and this and this going to the last handler, so we need to immediately give one message that this amount is not valid, right? And second thing is that for some ATM there is a maximum limitation. Minimum amount is this, maximum amount is this. You can also do those things as per your requirement, right? So we are going to implement these things, right? We are going to check how we are going to handle all these things, right? So let us create the abstract handler. Abstract handler means uh, definitely by looking at this abstract handler, you can consume that it is not going to be a concrete class. Let me first of all create one application chain of responsibility design pattern. Inside this behavioral design pattern folder, okay. Let me close all button, all window except this one, right? Let me create this as the startup project. Let me create an abstract class with the name handler.cs. This is going to be an abstract class. Abstract class means what? It is going to provide some of the basic functionality which are common to the next subclasses, and rest of the functions are going to be implemented by the concrete subclasses, right? So in this case, what I'm going to do, I'm creating the abstract class. This is the next handler. What is this next handler? It will hold the reference of the next handler, right? If you look at this image, 2000 handler, after doing the task, he needs to call the next handler in the request, which is 500 handler. How it is going to call that method? For calling the method, you need the reference object, and that reference object is nothing but in this case this next handler. And how it is going to set? By using this set next handler constructor, right? Method. So this set next handler method, it is going to set the next handler object of the current handler. For example, if 2000 handler is there, then I need to call this set next handler method. And while calling this method, right, using this 2000 handler object, I need to pass this 500 handler instance, right? That 500 instance will become here, and it will be set as the next handler for 2000 handler. Similarly, for 500 handler, who is the next handler? 200 handler. So for the 500 instance, you need to pass the 200 handler object, and that will be set as part of this next handler reference variable. We'll see how it is going to work practically. And this is the dispatch node. That means each handler is going to dispatch some node, right? 2000 handler is going to dispatch some node. 500 handler is going to dispatch some node. 1100 handler is going to dispatch some node. That means this dispatch note method is going to be implemented by each handler class and according to their business requirement. So the business rule, right? How many nodes are going to be dispatched by each handler is going to be vary from handler to handler. So we cannot put that logic here. But this logic is same. So I'm putting that logic here. But this logic is going to be vary from handler to handler. What logic, how we are going to implement that we will going to see. See, first of all, whenever the request is comes to this handler, what is the amount? 46,000 will come to this handler. After handling this, that means 46,000, this amount is nothing but the input for this handler. So that amount is going to be stored by this request amount variable, right? And again, once it handle, then again he needs to pass the remaining 46,000 for 4,600 for 4,600. So 4,000 is handled by this handler, remaining 600. So while calling the next handler method, he needs to put 600 amount, not the original this amount, right? That is one thing you need to remember, right? Let us implement the concrete handlers. So as per our requirement, how many concrete handlers we are going to develop? We are going to develop 4 concrete handlers. One is 2,000, then one is 500, one is 200, and another one is 100. Let me create the 2,000 handlers. Let me copy paste the code. The business logic is very straightforward, right? The business logic is very straightforward. So first of all, it will get the requested amount, right? So one, if you are calling this method means the amount what the user trying to withdraw is a valid amount, right? That validation check we will do later, right? But for remember, if I'm calling this 2,000 handler method by right, and if I'm calling this dispatch note method means the amount what I'm passing is a valid amount. So if the amount, once the amount is come, then first you need to check the number of 2,000 notes to be dispatched by this handler. So how many notes? So whatever the amount you are getting divided by 2,000, whatever the notes you will, whatever the value you get, right? That is nothing but the number of 2,000 notes. And in this case, if the number of 2,000 notes is greater than 0, then you will come inside, right? If the number of nodes is less than 0, then you directly go to here, right? Here you do not need to do any kind of a check, right? So you can see, right? So here you can see number of nodes to be dispatched, right? And here, if the number of nodes to be dispatched is greater than 1, right? So I'm saying this message, 2,000 nodes dispatched by the 2,000 handler. And if more than 1, then I'm going to 2,000 nodes is here are and here is. If more than 1, then I'm saying 2,000 nodes are. If it is 1, then I'm saying 2,000 node is dispatched by the 2,000 handler, right? After this logic, right, the next logic is nothing but this one. So this one means the pending amount, right? The pending amount means what is the pending amount that needs to be processed, right? And if the pending amount is greater than 0, then I'm calling the next handler, right? So I'm calling the next handler. If the pending amount is not 0, suppose the user sent 40, the user sent 4,000. 4,000 it can handle alone, right? Once the 4,000 is handled, if I'm doing 4,000 modulus operation 2,000, the remainder is going to be 0. So 0 is greater than 0, no. Then in that case, next handler is not going to be invoked, right? So this is the logic. And any question from anyone related to this logic? What I'm doing here, first of all, I'm calculating how many 2,000 nodes to be dispatched. If it is greater than 0, I'm coming inside. I'm writing here one if else condition because to make it grammatically correct, right? So if more than 1, then I'm saying 2,000 nodes. So number of 2,000. So 2,000 nodes are dispatched. It doesn't make any sense. 2,000 nodes are. The grammar is wrong. So that, and this is the reason why I'm putting this if else condition, right? If more than 1, I'm making this as R. If it is 1, then I'm saying 2,000 node is dispatched. And once the 2,000 nodes is dispatched, then I'm checking the remaining amount. Is there any pending amount to be processed? Yes. Then go and call the next handler. And while calling the next handler, the next handler for this handler is 5,000. So this next handler variable is going to hold the 5,000 handler. How it is going to hold that we will see later. But here next handler is nothing but the 500 handler, and that 500 handler class having this dispatch note method, same dispatch note method. Why? Because that 5,000 handler is also going to implement from this handler abstract class. So I'm going to call that dispatch mode method, but here I'm only going to send the pending amount, not the actual requested amount, right? So the next things is we need to implement the 5,500 handler. Create a class file. This is going to be 500 handler, and here the logic is going to be same. The logic is going to be same means it is also inheriting from a handler abstract class, or you can say it is implementing the dispatch note method of handler. So as you can see, this is a handler class. Handler means it's an abstract class. If it is an interface, you need to implement. If it is an abstract class, then you need to override that method. Here you can see overriding the method. So again, the same logic. We need to check how many 500 nodes to be dispatched. The number of nodes to be dispatched is greater than 0. Yes, go and check 0. If you want a node, then you have to write the logic accordingly 500 node. If more than one, then nodes are right. After dispatching the nodes, we need to check, is there any pending amount that is going to be processed by the next handler? Yes, there are some pending amount. If pending amount is there, then who is the next handler? For 5,000, for 500 handler, the next handler is 200 handler. So calling the dispatch node method of 200 handler, and the 200 handler is going to handle the request, right? Next, what we need to create? We need to create a 200 handler. So the next one is the 200 handler. The logic is going to be same, right? The logic is going to be same means it is the remaining amount it is received as input, and then it is going to check how many 2,200 nodes to be dispatched. If number of nodes is greater than 0, same if else logic, then it is going to check the pending amount. If pending amount is greater than 0, then please call the next handler, which is nothing but the 100 handler in the chain. So next, what we need to create? 100 handlers. Right? So 100 handlers. So this is the logic I have written here. But guys, remember in 100 handler, is there any next handler? So
No.
100
No, sir.
receive the amount. He check how many number of nodes to be dispatched, and it is going to dispatch the node. And here we do not need to check the next handler, because we know this is the last receiver in the chain, which and after this receiver no more receiver. So this is definitely the amount what is the user sent, that is going to be handled by the handlers, right? So these are the handlers. Now, so we have discussed the handler, we have implement the different kind of handlers, right? But the next important thing, how we are going to set the next handler, right? So for that purpose, I'm creating one class, right, which is going to chain the handlers together, right? So I'm going to use the client atm.cs, right? So as part of this class, what I'm going to do, I'm going to do the validation whether the amount is valid or not, right? And then I'm going to set the handlers. Handlers means for one handler, which is the next handler. So you can see I'm creating some private variables. So how many handlers are there? 1, 2, 3, 4. So 2,000 handler instance, 500 handler instance, 200 handler instance, 100 handler instance. So if the user wants to withdraw some amount, then he needs to create an instance of an ATM class, and he needs to call the withdraw method by passing the requested amount, right? And that requested amount validation we are checking here, whether that amount is divisible by 0 or not. If it is divisible by 0, means it's a valid amount. Otherwise, just say this message, you entered some invalid amount. And in this case, within this constructor of this ATM class, we are setting the next handler, right? So 2,000 handler. So for 2,000 handler, who is the next handler? See, this 2,000 handler, right? So this 2,000 handler means this is the handler. This handler, who is the superclass? For this 2000 handler, who is the superclass?
Handler.
Handler
Handler.
is a super.
In handler class, is there any method called set handler?
Yes.
Yes.
This set handler means it is expecting one object of handler type or not,
Yes, it's expecting the handler object.
right? So what
Handler
I'm
type.
doing, right? So who is background side is here, right? So here you can see for 2000 handler, I'm setting the next handler, and for setting the next handler, I'm again passing one handler instant, that is 500. For 500 handler, who is the next handler? 2000, 200. For 200, what is the next handler? 100 handler. But I'm not setting the next handler for 100 handler, right? So this is the logic which I have written to set the next handler. So when I call this method, right, that means it is going to set the next handler with one object or not. And that object I'm calling inside this method, right? That object I'm using here and calling the dispatch method, right? So next handler, so for 2000 handler, who is the next handler? 500. That 500 is going to store, 500 object is going to store inside this variable. And whenever I'm calling that next handler, the dispatch method, that means this dispatch method is going to execute from which class?
From the handler.
500 handler class, right? Clear, guys? So now we have created the ATM and setting the respective handler, doing the validation. See here, I'm putting this validation only. If you want, then you can also do some other kind of validation. What is the minimum amount? What is the maximum amount, right? Whether the PIN verification, whether the mobile OTP verification is required or not based on the amount. So those kind of validation logic you can write within this withdraw method. But those validation logic should not be as part of your dispatch method. If you are writing the validation logic here, then what will be the problem? The problem is you need to repeat the validation logic again and again in each and every method. And we are not going to do the repetition, right? Object-oriented programming means repeating code should not be there, right? So now what our requirement is, we need to create the user and we need to use the ATM class withdraw method, right? And ATM class withdraw method to withdraw the amount. So here you can see, if I'm sending 4600, then how many handlers is going to handle the request? Guys,
2 handlers, 2,200.
in this case, 300,
300.
2000 handler, 500 handler, and 100 handlers, right? In this case, 200, 500, and 200. 500 nodes.
500. So it'd be 2 handlers.
Right. In this case, two handler, one 500 node and one 100 node, and this is going to be an invalid amount. I'm also going to put some kind of a logic. So 46, 47, 47,000, right? I'm putting 47. So in this case, it is going to return me all the 4 handlers logic, right? So let me put this one at the top, right? 47 means all the 4 handlers will, not 48,000, right? All the 49. 4 handlers will come into the picture. No. All the 4 handlers, is there any combination where we can get to use all the 4 handlers? What is 28,000? Is that possible? 2,800? Yes. Okay. Let me run the application. uh, 2800. So 1 2000 node, 1 500 node, 1 200 node, 100 node. 46. 2 2000, 1 500, 100. And this one requested amount is 1900, 500, and 200. Requested amount is 6. So 1 500, 100. Requested amount is 750. You entered an invalid amount. Clear, guys? So in this case, the example what we discussed, in this case, one or more handler will come into the picture to handle the request, right? Multiple handler will come into the picture to handle the request. Clear? Now we'll see one example where only one handler is going to handle the request. There is no forward mechanism, right? Forward mechanism is there, but it's not possible that the logic should not be written in a way that there are two more methods are going to handle the request. So let us understand that with one example. First of all, you guys understand this chain of responsibility design pattern? Yes or no?
Yes.
Right. So the client is going to use the handler. Handler means it is concrete handler A, concrete handler B means what? In this case, this handler is nothing but an abstract class. And we have created four handlers. Handler 2000 handler, 500 handler, 1000 handler, like this, right? And this handler request means it is having success, means it is having a object, right, which is pointing to the same type of object, right? So this variable is nothing but handler, which is of type handler. This is what is showing in this successor, right? And client is going to use the handler, but simplify the client logic, right? We are introducing this ATM class, right? The client is going to use the ATM class and set the handler things, right? The next what we are going to discuss, the chain of responsibility design pattern, one more real-time example, right? Where we will see how only one handler is going to handle the total. Again, it is going to be a real-time application, right? So see, I'm trying to give you as much as a real-time application instead of giving those useless examples. And the examples which you are acquainted, I'm going to give such examples, right? So Amazon website, you are acquainted, I'm giving that example, right? This ATM machine example I'm giving because you are acquainted. And the next example, what I'm going to give, it is also related to one real-time example, right? So now we are going to discuss how we are going to implement the chain of responsibility design pattern where one receiver is going to handle the request, right? So this is nothing but hierarchy of an organization. So in an organization, if you are working as a developer, you need to report to your team leader. And your team leader will report to your project leader, and your project leader will report to the HR, right? I'm talking about for the leave application, right? For other kind of applications, right? Something it's different, right? For each organization, there are a different hierarchy is there, right? Let us assume this is the basic architecture, right? If you are working on a project, right, then that project having some project leader. If you are working on a team, then that team is having some team leader. And if you are working as a developer, then that is fine. So developer reporting to team leader reporting to project leader reporting to HR. And our requirement is we need to develop one application for leave management, right? Whenever a developer apply for a leave, the team leader have the capacity to approve maximum of 10 days leave. And this project leader having the capacity to approve 20 days of leave. And this HR can approve maximum of 30 days of leave. And as per the company rule, there is no more than 30 days leave is allowed, right? Now, now the developer applying for a leave of how many days? 25 days. If the developer applying a leave for 25 days, is that handled by this team leader? Yes or no? Guys?
No.
Why? Because the maximum capacity is 10 days. So as the team leader is unable to handle this request, so what he will do, he will forward this request to the next handler, right? Next, or you can say receiver in the chain. Who is the next receiver? Project leader. Is the project leader going to handle this request, leave request?
No.
Why?
No.
Because its capacity is 20 days. He cannot handle this. So what the project leader will do is he will forward the request to the HR. Is the HR going to handle the request? Yes, he is going to handle the request because his capacity is 30 and the user is asking for a leave of 25 days. So the point that you need to remember is, right? The point that you need to remember is at any given point of time, only one handler is going to handle the request. It should not be like that. Suppose the user is asking for a leave of 5 days. Then is that leave request is going to be handled by the team leader?
5 days, yes.
Yes. So 5 days is once he handled the request, then why is going to forward the request to the project leader and HR? Because 5 days is his capacity, and he checked whether yes, these 5 days other developers are there in the team. So you can take a leave of 5 days, so he can approve the request, right? But if not, it's beyond, then he will forward to the next. So the point that you need to remember is at any given point of time, only one receiver or one handler is going to handle the request, right? No more than. In previous example, we are having multiple handler handling the request, but in this case, multiple receiver are there. They are chained together, but at any given point of time, only one handler is going to handle the request, right? So let us see how we can implement this example using our chain of responsibility design part. Clear, guys? First of all, you understand the requirement.
Yes, sir.
Okay, let us implement this using chain of responsibility design pattern. Let me close all these things, close all documents. Okay, let me add a new project, chain of responsibility design pattern. Chain of responsibility design pattern example, right? Let us create the abstract class, that is employee leave handler, right? So we need to create the abstract class. Let me make this as the startup project. This is going to be my abstract class, and let me copy the code. So here you can see this is employee leave handler, supervisor, or you can say this is nothing but your next handler, right? So any name you can give. This is nothing but your next handler. If one a receiver unable to handle the request, he needs to forward the request to the next handler, and that next handler is nothing but your supervisor. And we are setting this value using the set next supervisor method, right? And this is apply leave. Here it is taking the employee name and number of days of leave, right, as a parameter, right? So this is the same. If you compare this example with the this class with the previous class, then the architecture is going to be same. You have to define one variable of the employee leave handler, or you can say this abstract class type. You need to provide one method where you need to set the value of this variable as, right? And you are having one method, abstract method, which is going to be implemented by the child classes, right? And as per our requirement, how many receiver we need to create? One is a team leader, one is a project leader, and another one is HR, right? Let us create these classes, right? Let me create the team leader class. Right, so this is my team leader class. What this class is going to do, if the capacity is in his control, then he will approve the leave, else he will forward the request, he will forward to the next supervisor, right? So it is inheriting or from this employee leave handler abstract class and implementing this apply leave method, right? Right. So what he is saying, see here I'm creating a static read-only variable, and the value is 10. Why? So this maximum leave can approve by team leader is 10. For that purpose, I am creating this variable. And in this case, we need to provide or we need to override this apply leave method, and that method is here. This method taking two parameters. What is the employee name or the developer name, and the number of days of leave. So employee name and the number of days of leave. So it is taking. So then it is checking whether the number of days of leave is in his control or not. If the number of days of leave is in his control, then he will approve the leave, right? So this approve leave method. So what I can do is, instead of creating this, so what I can do is separately. So unnecessary. Why I'm going to create a method? I'm going to write the code here, and I can simply ignore this one, right? So unnecessary code is not required, right? So if the leaf is in his capacity, then he will approve the leaf. Else what he will do, there is a property called supervisor, right? This is holding the next receiver object instance called the apply leaf method by passing the employee name and the number of days of a leave, right? So in this case, either he needs to approve the leave or he needs to transfer the request to the next handler in the chain, right? So now the next handler, what we are going to do is project leader. So project leader means its capacity is 20 days of leave, right? Let me create a class file with the name project leader.cs. So this is going to be our second concrete handler class. Copy paste the code, right? See, this is also here I'm creating one variable which is going to hold the number of a maximum leave this project leader can handle. You can get this value from the database, but I'm putting here, right? And here I'm checking whether the number of days what the user applied for is in his capacity or not. If in his capacity, then he is going to approve the leave. Else he is going to forward the request to the next handler, right? So is going to forward the request to the next handler. So let me delete this one, right? So and how it is going to forward the request to the next one? By using the supervisor. Supervisor is nothing but the variable which is holding the next receiver instance, right? And the next one is the HR class. So let me create one class file with the name hr.cs. This is the third concrete handler in our application, right? Again, let me copy this code, right, and put it here, right? And let me remove these things, right? So this is the maximum leave is 30. The logic is same. Logic is same means here if the HR is unable to handle the request, then what he needs to display this leave application suspended for employee. Please contact HR. HR suspend this. I mean from the portal it is suspended, and please go and talk to the HR. Then HR will tell that this it is your maximum or whatever the business logic, or else if you want to display that maximum 30 days, or you can say please contact HR. Before that you can say maximum 30 days of leave, or any kind of business logic you want you can display here, right? So we have developed the employee handler, and we have developed the team leader, project leader, HR, right? As per our application architecture. The next what we need to do is, see, in our previous example, we have created one hierarchy, right? For maintaining the hierarchy, we have used the ATM class, right? And that is optional, right? That is optional in the case. If you want, you can. Otherwise, you don't want, don't use that ATM class. Write the logic directly inside the main method. So here you can see I'm creating the instance of team leader. I'm creating the instance of a project leader. I'm creating the instance of a HR, right? For team leader, who is the if the team leader who is the next receiver for team leader, the next receiver is project leader. For project leader, who is the next supervisor? Supervisor is the HR. So I have set these things here. Else you can also create a different class, and as part of that class you can put all this logic as part of the construct, right? The way we have created in our previous example, right? Now the team leader, right? So what I'm going to do, I'm giving you some example, right? So team leader, this is the team leader. This is the first handler, or you can say first receiver in the chain. I'm calling the apply leave method, right? I'm calling the apply leave method for a user called Anurag and 9 days. So 9 days means this team leader is handled that request or not. What is the maximum? Maximum 10 days. And here the user Anurag asking for 9 days. So the team leader can handle the request. So in this case, you will see team leader approve the leave requests. Right now, Pranay is asking for 18 days. 18 days means it is in the team, it is on beyond of a team leader. So team leader cannot approve 18 days leave. So he will forward that request to the supervisor. So the supervisor for team leader is, who is the supervisor for team leader? For team leader, the supervisor is project leader. So the request will forward to project leader. What is the maximum capacity for project leader? 20 days. How many days the user Pranay asking? 18 days. So project leader can approve the request, right? And then another user is there, Priyanka, he is asking for 30 days leave. So let's assume that 25 days or 30 days less than equals to 30 days. So 30 days means team leader cannot handle, project leader cannot handle. The request will come to the HR. HR equals 30. Here we are writing the condition less than equals to. Equals to 30 means this condition is going to be satisfied. And finally, you can see, right? And finally, you can say Ramesh asking for 50 days leave. It is beyond the capacity. So even the HR is unable to handle the request and giving one message that please go and talk to the HR department, right? Let me run the application and show you the output. See, team leader approved 9 days leave for the employee Anurag. Project leader approved 18 days leave for employee Pranay. HR approved 30 days leave for the employee Priyanka. Leave application suspended for employee Ramesh. Maximum 30 days of leave. Please contact HR. Clear, guys? So in this case, you can see only one receiver is handling the request. Once the receiver handles the request, he is not sending that request to the next receiver. And partial implementation is not there. Partial implementation means if I'm asking for 18 days, don't think that 10 days leave is going to be approved by team leader and 18 days leave is going to be approved by project leader. This kind of a mechanism is not there. That is in the previous example. And this is the same thing is not applicable here. So basically, as per your business requirement, you need to decide how you are going to implement the application. Whether I need to split the work between multiple receiver. It's that possible using chain of responsibility design pattern like the ATM machine behavior? Yes, that is possible. Is it possible that only one receiver is going to handle the request? Yes, that is also possible. Example, this one. Clear, guys? Guys, clear or any question anybody have?
Yes.
Okay. So the last design pattern what we are going to discuss today is iterator design pattern. It is not that use design pattern, right? Mostly you will not find this kind of implementation, but as it's a design pattern, we are going to discuss this one, right? The iterator design pattern allows sequential access to element without exposing the inside logic. That means using the iterator design pattern, we access the element of a collection in a sequential manner without knowing its internal representation. For example, if you are having a collection, like list, array, right? And consider this is the collection. And this list, either you can take the example list, array, any collection. If they are storing some object called object 1, object 2, object 3, object 4, and then using a for loop or using a for each loop, you can access all the element of the collection in a sequential manner. But do you know the internal implementation of those of those data structure? How list is storing the data, how are list storing the data, how are storing the data? If you are using a for loop, how the for loop implemented in the logic inside it? Do you know all these things? No, you do not, right? Because these are already created by the Microsoft team. They are provided to us. And as a user, we are just going to use the collection. If you want to know the internal architecture, you can go and study, then you will be able to understand, right? But from the high level point of view, the implementation is hidden to us, right? So what exactly we need to do is, see, we need to design the application we need to design the iteration in such a that we are going to implement the internal logic. If I'm going to, for example, right? For example, if you look at this code, so I'm having the employee class, ID name is properties there. Employee constructor is there, which is going to set the identity name. I'm creating a list collection. I'm adding the element into this collection. I'm adding 1, 2, 3, 4, 5, 6 object into the collection, and I'm using a for each loop to sequentially access all the element of this collection. Here the for each loop sequentially access the element from the collection without exposing the internal logic. How it is internally accessing the element, how it is accessing the first element, how it is accessing the next element, how it will came to know that I have accessed all the element. Do you have any idea how the internal logic is implemented, guys?
No.
Right. So in this case, the for each loop accessing the element of the collection is of type list of employee. And if instead of a list of employee, if you take array list, do you think that the list, the way of storing the data, maintaining the data structure is same in the case of array list? Array list might be have a different data structure. Array might have different data structure. List might be have different data structure, right? That means they are going to store the data, handle the data in a different manner, right? So the data structure is going to be vary, and this for each loop, how it is implementing, right? How it is implemented that it can access all those data structure element sequentially one by one. If you want to know the internal architecture, right, or if instead of saying that, if you want to put all this list array in a common platform, in a common root, right, it doesn't matter, right? I want to design the iterator, right, where it is going to access all this data structure in a same manner. Then for that purpose I need to use iterator design part. For example, right, say in this case employee MP in collection. So here collection, it's a type of list of employees, so you are using like this. So instead of this, so what I'm going to use, I will create one class called iterator. Iterator that first means it is going to return the first element. Iterator that is completed, it is a property which is going to check whether the whether this for loop accessed all the elements or not. And iterator dot next means it is going to access the next element. So we need to develop such kind of some kind of application like this iterator, right? Internally, as part of this iterator, internally you can store the data in a list, in a array, in a array list, but from the external world we are going to access in the same manner, right? Doesn't matter whether the data is stored in a list or in a array list or in a array, right? The user, from the high level point of view, the user going to use the iterator class in this way. No matter whether behind the scene you are using array list or generic dictionary, doesn't matter. You have to use this one, right, to access the elements in a sequential manner. Well, see, in real time we are not using this one because the for each loop actually does the things behind for us. But if you want to know how it is implemented internally, then you need to use the iterator design part, right? So let me show you these things practically. So I need to develop one application where I need to access the element of a collection like this. How? Let us see. Let me first close all these things, close all documents, add a new project, iterator design pattern, make this a startup project. Okay, so let us create the employee.cs. So this is the item. Item means if you want to store something in the collection, you can store string values, you can store integer values, right? But I'm going to store some employee data. So for that purpose, I'm creating this employee class, right? So if you see this employee class having two properties, ID and name, and initializing these two properties using the constructor, right? If you are working with the if you are going to store some string value or integer value, then this class is not required. So this item means it is nothing but the collection item. The collection what I'm going to create, it is going to store this item. Next, what I'm going to create, I'm going to create I abstract collection, right? So I abstract collection means what I'm not going to use these classes, right? In the what I can say, inside the loop, I'm not going to use the list of collection. Rather, I'm going to use this one, right? I abstract collection, because in this collection, it is going to have right? One iterator class, iterator, create iterator, right? The following method is going to return an iterator object later. See how it is this create a iterator method going to return. If you look at this example, here I'm using the iterator. So this method is going to return an iterate, right? Right. So once you implement the example, then you will understand what is the create iterator method, what it is going to return, right? So please patience for some time because as we are using behavioral design pattern means we are communicating with the object. As we are communicating with the object means some of the object we created, it might be have some relation with the other object which you have not created. So in this case, iterator we have not created, but later we will create the iterator, right? So concrete collection means it is going to implement the abstract collection interface and it is going to provide implementation for this method, right? So here you can see I'm providing implementation for this concrete iterator. It is going to create the iterator object by passing this concrete collection instance, right? Later we will see what is this iterator class and the logic, right? So here list of employees. So here I'm using this list of employee. You can create array of employee. You can create array list of employee, right? That is up to you. So here I'm creating list of employees, and this iterator I will come to this part later. And this count method means it is going to return me the number of elements stored inside this count variable. Add employee means whenever you want to add any employee to this collection, you need to call this add employee method. Get employee method means this collection is going to store many number of employee elements. Based on the index position, I want to return the employee. So this is nothing but the index position. Index position 0 means the first employee which is added into this collection. Index position 1 means the second employee which is added into this collection. So that is what I am going to return using the index position, right? I will come to this part later, right? What is iterator? Because we have not created the iterator yet, right? So now it's time to create the iterator. So first of all, I need to create the abstract iterator. So abstract iterator means it is going to be an abstract class. Let me create the class file, right? Let me copy the code. So you can create this as an abstract class or an interface. As I'm not providing any common implementation, so it's better to use interface, right? So this iterator, right? So whatever the concrete iterator we are going to discuss, that is having three things, right? So if you see this picture, right, then I'm going to use the iterator that first method, iterator that is completed property, and iterator that next method, right? So these things I have declared here first. So it is going to return the first employee. Next method means it is going to return the next employee. Is completed property means it is going to return me whether the whether you have accessed all the properties or not, right? It is going to return. If all properties or if all elements are accessed, then it is going to return, right? So let me create, we have created the abstract iterator and this is the concrete iterator. It is the important class. This is nothing but your iterator design pattern class, right? So let me create a class file with the name iterator.cs. And then let me copy paste the code. So this class implements the iAbstract iterator interface, means it has to provide implementation for these three things, right? So, so if you remember, we have a concrete collection here, right? So what I'm doing here, I'm creating a variable to hold the collection elements, right? Concrete collection. Inside this concrete collection, there is a property called a list of employees, which is going to hold the list of elements. And again, count method is going to return the count, add employee, get employee, all these things are there, right? So we are creating this collection because we want to access the employee data. We want to see how many elements are there. We want to add employee, everything is there. So we want to use this concrete collection inside this iterator class. So current means 0. So what is this current? What is this step 1? I will explain you in some time. And this is the iterator class, right? Iterator constructor. And while you are going to create an instance of this class, you need to pass this concrete collection instance. And that concrete collection instance is going to store inside this variable, right? That is the job of the constructor, right? So next what I have to provide implementation for three methods. First, next, and this property is completed, right? First method means it is going to return the first element which is stored inside this uh, list of properties variable, or you can say this collection. So if you want to access this property, right, then what you need an instance of this concrete collection, right? So for that purpose, what I'm using, you can say I'm current zero, right? Current zero means what? Collection dot get employees. So first employee means if you go to this class, there is a method called get employee, and this get employee method, what it is taking? It is taking the index position, and based on the index position, it will return the element from this collection, right? And what I'm doing here, I'm using this collection, right? This collection is nothing but a concrete collection, which is nothing but this type. And once you create an instance of a concrete collection, then you can call this get employee method by passing the index position. So that is what I'm doing here. I'm creating an instance of a concrete collection, calling the get employee method, passing the index position. And what index position I'm passing here? I'm passing current. Current means zero. So this is nothing but a current element. The first element I want to access. So that is what going to be written by the employee class, right? So next what? So once the first implementation is done, then what we need to do? We need to access the next element. So if you see, there is a method called the next element. Once you access the first element, and then in that time you are setting the current value as zero. So as you are setting the current value as zero, to access the next element, what you need to do? You need to take this current value, whatever. Say it might be possible that next element, so suppose next element current value, then you need to add this step means value 1. So once you access the first element, the next element is nothing but the index position 1. How you will get the index position 1? Just add current plus step. So that is the use of this step variable. So current, which is current value, is 0, step which is value is 1. Doing this addition, the result will be stored inside this current value. So current is 1. So then I'm using this is completed property, right? So is completed. So if you see this is completed, it's a property. And what this is completed is going to do, it is going to check the current with the collection.count. So if you go to that, this collection, this is a count property, which is going to return me the list of element. Let assume we have added 3 elements, right? Let assume this list of employees contains 3 elements. So once this list of collection contains 3 elements, once you access the first element, this first is nothing but accessing the first element. Then what will become this current value? Current value become 1, because 0 plus 1, 1. So 1 means it is going to check whether you have accessed all the element or not. So here current means 1. 1 is greater than list of count. What is the list of count? List of count is 1. List of count, it is going to return the number of elements stored inside this variable. What it return? 3. 1 is greater than equals to 3. Condition is true or false? Condition is false. So if condition is false, then I'm using not operator, means it will become true. Then it will return the current element from the get employee method. What value I'm passing? I'm passing 1. So 1 means it is going to return the element from this collection whose index position is 1. So the second element it is going to return. So once the second element is written, again you are calling the next. So it is already 1. 1 plus 1, it is becomes 2. 2 means again it is going to check the condition, right? 2 means what? 2 is greater than 3, right? So in this way, it is going to access the element one by one. When this current value becomes 4, right, like this, then this condition become false. And once the condition become false, it is going to return null. That means it is going to access all the elements sequentially one by one. Now let me copy this code into the program class and see this. See, I'm adding some element collection 1, 2, 3, 4, 5, 6 element. I'm creating the iterator. Iterator nothing but this create iterator method is there. Where is that create iterator method? Collection dot create iterator. This is create iterator. So when I'm calling this create iterator, it is going to create an instance of the iterator class. So whatever the class I have discussed here, it is going to create an instance of this class. and return that instance. What instance it is going to return? Iterator instance. So in this case, you can see create a iterator. This method belongs to our concrete collection class, but this method going to return me an iterator instance. And once the iterator instance is returned, so while if you are using a loop, then three things is required. What are the three things? One is what is the first element when the condition is going to be false, and what is the next element. So here you can see iterator the first, it is going to return me the first element. Then that element information will be printed here, right? Then is completed, then it will check whether you have accessed all the element from the iterator. No, I have not accessed the element. Then please access the next element. Once you access the next element, that element information will be stored inside this EMP variable. Then print the data again. Access the check after accessing this next element. Check whether you have accessed all the element or not. If you have accessed all the element, then this condition will become true, and as we are using this not operator, it will become false. So it will go outside of the iterator. So in this way, you can access all the elements of the iterator. Right. So let me run the application. See, I'm iterating over collection, and sequentially I'm accessing all the elements. Right. But generally you will never see any kind of logic like this, because we are very much acquainted with for each loop, right? So if you see for each, right, so simply what you can do, you can use this collection, and you can simply put like this. Now let me make this as public for some purpose. Right, so you can access like this. So instead of doing these things, we are very much acquainted with this one, and you can get, and you can run the application, you will get the data as expected. See, but to understand how internally they have implemented the iterator, you need to understand these things, right? So there is some collection, they are storing the data. We need to use some kind of first, last, first method, next method, right? And you need to access the element one by one, right? But this is not generally used, because we are very much acquainted with this for each loop. Clear, guys? So tomorrow we have class, same time, 7 to 9 or 9:30. Tomorrow we are going to discuss more design patterns. So please attend the sessions, right? Thank you, guys.
Thank you, sir.